Kia ora Year 12, here's question 5 from the May 2018 stats paper. Okay, so this one is another normal question. The mass in kilograms of rocks in a certain area has mean of 14.2 kilograms and standard deviation of 3.1. Now notice that we're not told that the rocks are normally distributed, and they might be any kind of distribution. But what we're asked to do here is to find the probability that the mean mass of a random sample of 50 of these rocks is less than 14 kilograms. So you should already be thinking, well, I've got a big sample of 50, so I can use the central limit theorem. Otherwise, we've got no way to solve this problem. And it turns out that the second question is going to ask you about exactly that. But what we can say now is that if the mass of the rocks is x, we're trying to do something here with x bar. And we can say that x bar is roughly normally distributed, and it's going to have a mean of 14.2 kilograms, and it's going to have a variance of one of those rocks, which is 3.1 squared, divided by n, which is 50. Now we have to find the probability that the mean is less than 14. So we're going to standardize, and we get z is less than 14 minus the population mean divided by 3.1 over the square root of 50. Okay, so that gives me the probability that z, this works out to be negative 0.456. Now, I know most of you are not sketching these as you do them in a hurry. I still really would like you to, but never mind. So just in case you're not getting this question dead right straight away, this is what we're doing. We've got a z value here of negative 0.456, but using our table, we have to work with what we're given here, which is the area less than 0.456. So what we want to find is 1 minus the CDF value of the positive number. All right, so that works out to be 1 minus 0.6758. And for four sig figs, we get that, but we have to round to 3 significant figures. So there we go. That's the first part done. Now there's just a 1 mark follow-on question about the central limit theorem, which is this. So explain whether it was necessary to assume that the population of the masses of these rocks is normally distributed. And no, it wasn't. So I'll just write something down there. Since the sample size is bigger than 30, try and put that into a proper sentence. Since n is bigger than 30, we didn't need to assume weights or masses, I should say masses, were normally distributed. Because the central limit theorem, something like this, applies. So there you go, that's that. I'll come back with number 6 and 7 shortly.